Hi there. The following is a video for Unit 3, Section 2 guided notes. And what we're going to be talking about today is function notation. So what you've normally been used to is these linear equations where you're writing them as such, where you would write something like y equals 3x plus 2, okay? Now, when we talk about a function notation, because this is a function, okay? For each x, there's exactly one y value. If I wanted to graph this, you know, it would pass the vertical line test, all that good stuff. But if I wanted to, you know, when I have this is not in function notation. Even though it technically is a function, I'm not writing it as a function. So this is not in function notation. Comma, but it is a function. All right? So what I want to do is, in order to write this in function notation, I would write this like this. I would write f of x is equal to 3x plus 2. This is function notation. Okay? And I could also write this as, say, g of x equals 3x plus 2. All right? And these things are the same as y equals 3x plus 2. It's the same relationship. It's just written differently, okay? Now, the reason why we use these letters with a parenthesis and then x is to denote a function in terms of x. So you have this function, f of x is equal to 3x plus 2, and you can also call it g of x equals 3x plus 2. Now, here's one of the main reasons why we do this, all right? So let's say that I wanted to find my goal is to find points on the line y equals 3x plus 2. All right, so what I would do is I would have to do this. I would have to say, okay, well, let's let x be equal to, say, 2, and then what's the y value equal to? So if I did that, then, you know, I'm just taking 2 and I'm plugging that in for x. So y equals 3 times 2, and then plus 2, and we end up getting y equals 6 plus 2, so y is equal to 8. And then what we can do is we can come in here and we can say, all right, well, that means that I have the point, so you have the point on the graph, 2, 8, all right? And that's the idea. Now, in function notation, so using function notation, that actually is a lot easier, all right? And so what I can do is, instead of saying let x be equal to 2, what's y equal to, I'm simply just going to go, what's f of 2? And when I have f of 2, I'm just going to plug that into the function, and it's going to be 3 times 2 plus 2. And then I do the math and I write f of 2 is equal to 6 plus 2, and then I write f of 2 is equal to 8. And this means f of 2 is equal to 8. What that means is that x is equal to 2 and y is equal to 8. And I can then write that as a point 2, 8. And so the whole point of this, friends, is that you have all these different kind of ways of writing the same thing. And instead of using y, we're going to use f of x or g of x, whatever the function is. All right, so that's kind of the idea here, is that, you know, we've been dealing with these equations. Are they functions? Maybe, maybe not. Well, if we write them in function notation, then we know that they are functions, okay? And so that's kind of the idea. So what I'm going to do is we're going to do a couple of examples. We're going to evaluate functions. So we're going to evaluate each function for when x is equal to 4. So I have this function here, g. g of x is equal to negative 2x minus 3. Now remember that this is the same relationship as y equals negative 2x minus 3. Okay, it's just written in the form of g of x. So what I want to do, if x is equal to 4, I'm going to plug that into my function. And I'm going to calculate, well, what's g of 4? And so I'm going to take negative 2 times 4 and then minus 3. And then g of 4 is equal to negative 8 minus 3, which ends up giving us that g of 4 is equal to negative 11. Now remember what this means. This is a point on the graph, okay? And what my goal here is that I want to, identify that this is the point. Here really x is equal to 4, y is equal to negative 11. That's the idea. And that then gives me the point 4 comma negative 11. Okay, but we need to be able to read this and understand what that means. All right, let's take a look at the next example. This one, you have this function h of x is equal to 7x plus 15. Now again, this is the same as writing y equals 7x plus 15. That's the idea. But we're plugging in 4 for x, so h of 4. And then wherever I have x in my function, I replace it with 4 and I do the math. So I'm going to do 7 times 4 plus 15. And then h of 4 is going to be 28 plus 15, which ends up giving us a total value of 43. Now again, what this means, all right, that's our answer, but remember that this is a point on the graph, all right? And so our goal here is to, understand that x is equal to 4 and that y is equal to 43, and that you have the point 4 comma 43, and that's the point on your graph, okay? All right, let's take a look at this next one. And it says, evaluating functions, what is the value of f of negative 8 if f of x is equal to negative 5 times x minus 8? So it wants us to find the value of f of negative 8. So I'm going to plug in negative 8 into this function. And I'm going to do negative 5 times negative 8 minus 8. F of negative 8 is then equal to negative 5 times negative 8 is positive 40 minus 8. F of negative 8 is equal to 32. And that's it. That is your answer. What is the value of f of negative 8? If that's what it's asking for, plug in negative 8 into your function, and it spits out an output, okay? All right, so now we've got this problem down here that says writing functions. So write a linear function for the data in each table using function notation. So, what I want to take a look at here is, let's just make sure that it's linear. So the x values are increasing by 1. The y values are increasing by 3. So what we can figure out is we can figure out our slope. We know that our slope m is equal to 3 over 1. The change in y divided by the change in x, m is equal to 3, okay? So from here, what we have, instead of writing y equals mx plus b, I want to write f of x equals mx plus b. And the thing is that when I look at this table, right, like I can use any of these points. And because these are points, I can write them using function notation. So what I can do is I would probably use this one. I would use that f of 1 is equal to 1, but I could use this one, and I could use that f of 2 is equal to 4. Again, x value, y value, input, output, all the same stuff. So that's the thing, is that once I'm here, I'm going to use my slope, all right, which is 3, and a point, and I'm going to take these values of 3 and that point, and I'm going to plug them into here. Now, what I've got is that f of 1 equals 1, and this is kind of the tricky part, and this is the part where it can confuse people, is that you can write f of 1 here is equal to 3 times 1 plus b. But knowing, and it's kind of weird because we're dealing with 1 and 1, f of 1 is equal to 1. So like, you're used to just seeing this where you just plug in like 1 and 1 into x and y. But I'm going to do the same thing. And even though f of 1 is equal to 1, I'm going to replace it with 1, and that's equal to 3 times 1 plus b, and then 1 is equal to 3 plus b. Therefore, I can solve for b by subtracting 3 from both sides, and I end up getting that negative 2 is equal to b. So that is my y-intercept, and I can write this whole answer here as f of x is equal to 3x minus 2. And that is what we were being asked to do, write a linear function for the data, okay? All right, on this back side here, all right, let's take a look at these application problems. So on this first one, it says Tamika records the outside temperature at 6 a.m. The temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the temperature be at 2 p.m.? So here's the thing. When I write this out, I want to write a function. All right, so I'm going to write f of x is equal to mx plus b. And what I want to think about is my slope. What's my rate of change? And that's this, that the temperature increases by 2 degrees Fahrenheit every hour, okay? And so when I think about that, that's a positive slope. So my m value is equal to 2. The next thing is my y-intercept, my initial value. And so what we want to look at is this picture here and realize that at 6 a.m., all right, the temperature is at negative 3 degrees Fahrenheit. So b is equal to negative 3. So if I wanted to write my function, I would write f of x is equal to 2x minus 3. All right, and that's going to represent this situation. And what we want to figure out is what will the temperature be at 2 p.m.? So the thing is that from 6 a.m. to 2 o'clock p.m., how many hours is that? And from 6 a.m. to 12 is 6 plus another 2. This is going to be a total of 8 hours. Okay, so what I'm really finding here is f of 8. And that's equal to 2 times 8 and then minus 3. So f of 8 is equal to 2 times 8, which is 16 minus 3. So f of 8 is equal to 13. And interpreting that, that means that the temp is 13 degrees Fahrenheit at 2 o'clock p.m. And then the question asks, does this linear function realistically represent the temperature for the domain of 0 is less than x is less than 24? Explain. And what I'm going to say here is that no. Because what this is saying is that this is a 24-hour period. All right? And the one thing that we want to recognize here is that in this scenario, all right, the temperature increases by 2 degrees Fahrenheit for every hour for the next 6 hours. That's not going to happen for 24 hours. So this might likely be like a 12-hour period. And so, to explain this, like to answer this question, I'm just saying no. To explain it, I would say that the temperature rises only during the day and not at night. All right, so a more realistic might be, between 0 is less than x is less than 12 for maybe a 12-hour period. And it sort of depends. Like this is, because this, I'm assuming that this is winter, it may not be even 12. It might be like an 8-hour period, something like this, or maybe like a 9-hour period because the sun will set well before, 6 p.m. and stuff like that. So just something to think about. All right, let's take a look at this last one here. So let's read this one. And what it says is a chairlift starts 0.5 miles above the base of the mountain and travels up the mountain at a constant speed. How far from the base of the mountain is the chairlift after 10 minutes? So we've got a couple of things here. What we know is that you've already traveled 0.5 miles from the base. And the chairlift travels 6 miles per hour, and it takes 15 minutes to reach the top. All right. So here's something that we can figure out. First of all, let's label our x value and let's label our y value, f of x. Okay, so x is going to be minutes. And f of x is going to be the distance traveled. All right, so the distance traveled. Now, one of the things that we've got to consider here is that, we want to write this in the form of f of x equals mx plus b. We already know that we're 0.5 miles from the base. So we already know that our b value is 0.5. But what we don't know is we don't know our m. Now, we sort of do know our m because we're traveling 6 miles per hour, all right? And we want to be talking about minutes. So how far are we traveling per minute? So one of the things that I want to do is do some conversions here to put this into minutes. So I'm going to multiply this by, 1 hour is 60 minutes. And if I take 6 and divide it by 60 and our hours go away, we're going to get 0.1 miles per minute. All right, and that's going to be our slope. So our slope is going to end up being 0.1. So we can write this and we could say f of x is equal to 0.1 x plus 0.5. All right, so now, what we want to figure out is, how far is the base of the mountain after 10 minutes? So if I plug in and find f of 10, that's 0.1 times 10, all right, and then plus 0.5. So 0.1 times 10 is just going to give us 1 plus 0.5, and that's f of 10. And then f of 10 would then be equal to 1.5. So this would be 1.5 miles up the mountain, all right, and that's interpreting that, all right. And that's our answer, okay, for that part. All right, so let's talk about this. So on this one, it says, kind of the same question. And, a chairlift starts 0.5 miles above the base of the mountain and travels up the mountain at a constant speed of 6 miles per hour. How could the function, graph, and equation change if the speed is 4 miles per hour? All right, so one of the things that I want to do is I want to determine, we already know that our b value is 0.5. We want to figure out our slope. So if I do 4 miles per 1 hour times 1 hour over 60 minutes, then that's going to end up giving us like 0.0666, all right? And that's in miles per minute. But let's simplify this fraction. Let's say if I have 4 over 60, each of these are divisible by 4, which would end up giving us 1 over 15. I'm going to put this as a fraction, and that's miles per minute, okay? So our equation, our function, the way that would change is we would get f of x would then become 1/15 x plus 0.5, all right? That's how our function would change, all right? And the only thing that's changing is our slope. All right, so that's all I've got for this video. Hopefully you enjoyed it. Please reach out if you have any questions, and we'll talk to you soon. Thanks a lot. Bye.